Hello, this is Renee Robinson, and I will be working a limiting reactant problem from the modern chemistry textbook that you see in the upper left-hand corner. This problem, if you would like to follow along, is number 1A on page 294. The problem reads, carbon disulfide burns an oxygen to yield carbon dioxide and sulfur dioxide according to the following chemical equation, which we see here. If we have 1 mole of carbon dioxide or carbon disulfide is combined with 1 mole of oxygen, identify the limiting reactant. So first off, we need to notice that this 1 mole of carbon disulfide is right here, and the 1 mole of oxygen gas is right here. Whenever you are given a limiting reactant problem, you will always be given 2 measurements of a reactant. And that kind of tells you that, oh, before I figure out anything, I have to find this limiting reactant. Now, by definition, the limiting reactant is what limits the amount of these products that are being made. So there's 2 ways of doing this. I'm going to show you one method where we compare the moles of each reactant. So the first step of the problem is always to notice or check if you have a balanced chemical reaction in any stoichiometry problem. Here I notice that I am balanced. Luckily, they've already given me a balanced equation, so I don't have to do so. So the second step in the method I'm going to show you is to find moles. A lot of the times, these givens that they give you here can be given in grams. If they did give it to you in grams, you would want to go from grams to moles in this step. But they've already done that for us, so we don't have to go any further. You find the moles, and that's done for us. The moles of the reactants, that is. Okay, so the third step of the problem is to go from moles of one reactant. So basically our mole-to-mole problems. Moles of the reactant number 1 to moles of the reactant number 2. Okay, so to do that, we just see what's given to us. So I'm going to start off with the carbon disulfide, which is this one. So 1.00 moles of carbon disulfide. And you go from moles of one reactant to moles of the other. So my reactants here are carbon disulfide and oxygen gas. And then I'll do it again from oxygen gas to carbon disulfide, and then I'm going to compare. Okay, so 1 mole of carbon disulfide. When we're going from mole to mole, we need to cancel our moles of carbon disulfide, so I'll put that down here at the bottom. And I'm trying to find moles of oxygen, so I'll put that on top. Since this is a mole to mole ratio, as we see here, mole to mole, then we pull from the balanced chemical equation. So a 2 is in front of oxygen, and a little invisible 1 is in front of carbon disulfide. Okay, so if we're doing that calculation, our moles of carbon disulfide cancel, leaving us with moles of oxygen. 2 times 1, we can all do simple math, is 2. So 2 moles of oxygen. So what this is telling me is that when I have 1 mole of carbon disulfide, I need 2 moles of oxygen to react perfectly. Okay, if you notice, though, I need 2 moles of oxygen to react with my 1 mole of carbon disulfide, but look what they gave me here. They only gave me 1. So before I do, I just did this calculation here. Before I do this one, my first guess is already that oxygen is my limiting, since they gave me less in the problem. They only gave me 1 mole of oxygen, and I need 2 moles of oxygen here to react with the 1 mole. I hope I'm making sense. Okay, let's do the next calculation, and hopefully you'll see. Okay, so the next calculation, I've already done this one. The next one will go from oxygen to carbon disulfide. So, given in the problem, because we always start with the givens, 1 mole of oxygen gas. I need to cancel my oxygen gas, so I'll put moles of oxygen gas on bottom, and I'll put moles of carbon disulfide on top. Since it's a mole to mole, we pull from the coefficients. There's a 2 in front of the oxygen and a 1 in front of the carbon disulfide noticed here. Okay, so 1 divided by 2 Again, simple math. So basically 1/2, 0.5 moles of carbon disulfide. Okay, so this tells me that for every 1 mole of oxygen gas, it requires 0.5 moles of carbon disulfide, 0.5 moles, to react perfectly. If I look what's given to me in the problem, I'm given more than that. See over here, I'm given 1 mole of carbon disulfide. So that tells me that, again, I'm going to have excess carbon disulfide, and oxygen is going to be what limits my reaction. So my limiting reactant here is oxygen. And I hope that you guys can understand and see why. Thanks for watching.